Hello and welcome back. My name is Omar Santos. In this video, I'm going to walk you through different exercises for learning how to exploit vulnerabilities in web applications using the OWASP WebGoat environment. Let's get started. Alright, we're back to Websploit, and in this case make sure that your Docker service is running. You can do that by just typing docker ps. As I mentioned to you in the previous videos, I do not start the Docker service by default at boot time in Websploit to avoid having the Docker containers being exposed by default in your configuration. If you have not started Docker, basically you can do that with the service docker start command, and of course I already have it running, so I'm going to cancel that. And then you see that we have all the containers running, and specifically we want to actually play with WebGoat today. And WebGoat is actually running on port 8881, so the local host is mapped or port 8081 in the local host is mapped to port 8080 in the container. So if I go to my browser, I will navigate to my IP address. In this case is 192.168.88.164 colon 8881, and make sure that you type WebGoat. So the W is uppercase and the G is also uppercase. And then once you actually try to, you navigate to that page, you will come to this login page, and you do have to register a user. And the reason for that is for you to be able to complete the exercises and keep track of your progress, right? So WebGoat is an application that has been used for many different, not only teaching, WebGoat is an application that has been used by many individuals not only to teach, but of course to practice, but also in capture the flag events. And it allows you to track your progress and whatever exercises you actually have completed or still have to complete. So for that reason, you actually can click on the new register a new user and put a username in there and a password. I already have a username just called test user, as you see in here, and I'm gonna enter my password. And as you can see, WebGoat is an application that will not only have different exercises, but it will guide you through different explanations of vulnerabilities that are very common in web applications nowadays. And it's typically aligned with the top 10 vulnerabilities from OWASP. And by the way, this is an application that was actually created, it's a project, a mature project in OWASP, right? And in the previous videos, you already explained to you what OWASP is. It's a non-profit organization, international organization that has many individuals as members. As a matter of fact, I'm a lifetime member there, and I even have a OWASP email address. However, you can collaborate with others and of course learn from the many different resources that they have. So this is actually one of their mature projects. Now, if you navigate to some of the exercises, for example, let's navigate to injection, and then let's click on SQL injection intro, which is an introduction of what, not only what SQL injection is, but what actually SQL or the structured query language is all about, right? We're not gonna go into every single exercise in here. There's several exercises that we actually have within WebGoat. As a matter of fact, if you click in the report card up here, you can actually see that there are 31 lessons and 76 assignments. 76 assignments means 76 different exercises within those lessons. I already have solved one, but that's what we're going to be solving right now, the first one in here. So if you click on 2, you see that actually the application is telling you what is SQL. It gives you a table or a SQL table, right, of a database that is actually in the back end of this application. And basically, it asks you to retrieve the department of one of the entries in here. In this case is Bob Franco that you see here. And we only want to actually create a SQL statement that will only return the department. So to do so, we can do things like select department from employees, because this is actually the name of the table, and then where first underscore name equals Bob, right? So if you see in here, we have first name, last name. We already knew that the employee or the database table is called employees, right? As you see in here, and as a matter of fact, it's lowercase, as they explain in the text here. And then basically I'm doing with a single quote, I'm just looking for anything that matches the first name of Bob. So if I click submit, you actually see that we actually have successfully completed that exercise, and the department is actually marketing. So this is not hacking by any means. This is not even a SQL injection. It's actually explaining you how to navigate through, different manipulation and different type of queries, SQL queries for the, for these applications, right? So there's different SQL statements that basically applications can use behind the scenes, like select and insert and update, delete, and many others, right? And from an attacker perspective, what we want to do is try to find input validation issues that will allow us to then create our own SQL statements and do many different things to a database. That can be retrieving records, that can be altering some records, and so on, right? And by the way, actually, let's just jump into an example on how to alter, one of the operators in here, right? So the exercise is actually is asking you, try to grant the user group unauthorized user the right to alter the table. Now, in this case, we're not going to be using a SQL injection. It's just asking you to enter some SQL query to do that. And then later, you're going to see how SQL injection comes into the mix, right? So in this case, it's actually asking me to grant the user group unauthorized user the right to alter tables. So what we can do is actually use the grant SQL statement. And then in this case, we want to alter table 2. And then in this case, unauthorized user, right? Just like it says in here. If you click submit, you see that we actually were able to grant and as you've seen here, you can see that we were able to grant the user group unauthorized users the right to alter that table. Now, if you click through the explanations, that we're not going to go that in here, I will strongly suggest that you do, right? Especially to understand, just like the screen says in here, the consequences of SQL injection. What is SQL injection is all about. There are different types of SQL injection vulnerabilities, right? There is blind SQL injection, and that means that you do not see the results probably coming back as you saw before to the screen, but you may be still able to delete records, modify records, what we call drop tables. In other words, actually, erase the records of a given table and so on. Now, there's also different vectors of SQL injection that you will be learning throughout this 10-week program, where you can do things like Boolean SQL injection. You can do things like time-based or error-based SQL injection vectors, union queries, and many others. So in this case, actually, this is fairly simple, right? What is trying to demonstrate to you is we have a table here that is actually called user data, right? And then in this case, we're actually looking for a specific first name. In this case is John, and the last name of, whatever last name that we're actually having here, right? So using the form below, right, we want to retrieve all the different users using SQL injection, right? And basically what we a few things that I want to highlight in here. First is that in a real world application, everything that you see here is sent by the application to the database by, behind the scenes, that the user will not be able to actually see this, right? But if you had something like a form, right, and where users can actually enter some input in here, basically what you can do is try to escape, and typically you'd use a single quote. Escape, what we call escape the input, for you to actually start putting your own SQL statements, whether it's Boolean SQL statements or union queries, as I mentioned to you before. Now in this case, what we're gonna be doing is we're gonna create a Boolean statement, and the application is actually doing it already to you, right? So it says single quote Smith or 1 equals 1, and then get account info. But you have different options on how to do this, right? So if we do 1 equals 1, probably, it's not gonna work. So what we're gonna try to do is a single quote, right? And then after that, 1 equals 1. But in this case, I'm actually gonna be putting the first one between single quotes and then closing the first quote that I had, right? And then putting the other one. That actually will make it so that the database will treat this as true, because 1 equals 1, and it will actually try to then display all the different records of the database. So if I actually click on get account info, now you see that we are able to see all the different elements or the different entries or records of that database table, right? So in this case, the database table is user data. And you see Joe Snow, John Smith, Jane Plain, and many, many others. So that was too simple. Let's go over the next one, right? This one is a numeric SQL injection. And let's read what the exercise is actually asking us. The query in the code builds a dynamic query as seen in the previous example. The query in the code builds a dynamic query by concatenating a number, making it susceptible to numeric SQL injection. And basically you can see here that we have a select statement, again from the same table, where logging counts, and then in here we have a double quotes, and then we see logging count plus and user ID, and then of course the user ID afterwards. So using the two input fields below, right? So that's logging count and user ID, as you see from each of the elements. What we're gonna do is actually trying to find the way to successfully retrieve all the data from this database. Now, logging count, you can expect that is some digit, right? Some in this case a number, right? So we can actually start with 0. Let me put 0 here. And then down below, remember that we were actually trying to do the Boolean statement with OR. We can actually try to do 0, which is also true here, and then OR 1 equals 1. And in this case, we don't need the single quote. We're not escaping anything. We're actually just trying to retrieve this. And then you see we're actually successful to retrieve the information. And basically, this is another example of a Boolean SQL injection using the OR operand in here, right? And since this application is susceptible to numeric SQL injection, that's the reason that we were able to retrieve all the records in the screen. So let's take a look at another example. Let's go to 11. And then in here is another exercise that, of course, related to SQL injection. And just go straight to the exercise. Basically, what it's actually asking is, you're an employee named John Smith working for a big company. The company has an internal system that will allow all employees to see their own internal data, like the department that actually work and the salary. Typically what we are similar to what we saw before, right? And it says the system requires that employees use a unique authentication, or TAN, T-A-N, to view the data. And my current, in the case, of course, of us as John Smith as employee, the current TAN is this string in here, so 3SL99A. So since you always have the urge to be the most earning employee, you want to exploit the system, and instead of viewing your own internal data, you want to take a look at the data of all your colleagues to check their current salaries. So basically it's asking you to use the form below to retrieve information, from the employees database, and you should not need to know any specific names or TANs. So that's another hint in here to be able to get the information that you have. And you see the example of the actual SQL query, and you see from employee, word, last name, and then of course the name and the authorization TAN, right? Or authentication TAN, and then of course the actual value. So in the employee name, we probably can put anything, right? Probably like an A. And then from here, what if we actually try the same query that we did in the second to last exercise whenever we were escaping the Smith username, right? So in this case, it's another Boolean similar to what you saw before. I'm doing a single quote and then one between quotes, and then I'm going to escape that again, and then one, right? And then if I click on get department, you see that now we're actually able to compromise the confidentiality of the database by viewing all this other internal information. We get the authorization TAN from many other people, right? So again, that's actually another example of using Boolean SQL injection. Now let's go over an advanced one, right? Let's click on number 3, right? So I navigated to advanced, number 3. And then in this case, it's going to be a little bit more, just as it says, advanced and complicated. So the title is Pulling Data from Other Tables, right? And basically, you are getting already some SQL statements to create a user data table, right? Or a table called user data. And you see that, of course, has different fields. It has user ID, first name, last name, credit card number, credit card type, and cookie, and login count. And then it says, through experimentation, you found that this field is susceptible to SQL injection. Now you want to use that knowledge to get the contents of another table. And the table that you want to pull data from is this actually other one, user system data. And you see a few of the fields in here, right? Now the first thing is that we have to retrieve all data from the table. And then whenever you have figured that out, we have to see or try to retrieve Dave's password, right? Now, pay attention to the notes. In some cases, actually, they're going to give you some hints. In this one, is saying that there are multiple ways to solve this assignment. One is actually using an union query, right? And the other one is actually trying to append a new SQL statement. Maybe you can find both or so on, right? So let's do both, right? At the same time. So the name is something that we want to probably mess with, and then of course it also asks you that if you figure out how to retrieve the data from the table, then we actually probably have to get Dave's password. So first, let's actually try to escape from the beginning. And as a matter of fact, in many cases, whenever I try to see if an application is susceptible to SQL injection, literally I just do a single quote. This is actually the poor man's of checking if an error message is actually going to come back. Most definitely this is actually not going to be doing much, right? Because already there's some checks on the back end of this application that is probably not going to give you a real life error, right, from a SQL injection. This case is just saying malformed string, right? But in many cases, actually, literally, you just go to different input fields, put a single quote, and you may be surprised. You may actually get some error messages that will give you additional information about the database. And then from there, you can start creating your own SQL or SQL injection vectors, right? So let's go back to the exercise. And in this case, after the single quote, I'm going to do a semicolon. And I'm going to put my own select statement. And as a matter of fact, I already have it down here, right? But I'll walk you through this. Select star. So I want to retrieve all the different entries of the user system data table. So that's the reason that you see here from user system data. And let me make it a little bit better for you to see. And then after that, I'm going to do a semicolon. And then at the end, I'm going to do a comment with the dash dash, right? And in this case, actually, our SQL query needs to end with a comment. And another thing that I want to highlight is that whenever you're using either a union query or a select statement, each of those statements will actually have to have the same number of columns. So the data type of a column in the first select statement needs to have a similar data type that is actually in the second select statement, which is the one that actually I'm putting here. Right? So the first one is the one going behind the scenes that the application is sending to the database. And then in this case, I'm actually trying to retrieve everything from that table using the second, I guess in this case, select statement. And later we're going to try to do it with a union select as well. So if I click on get account info, you see that now we're actually able to retrieve all the different username and passwords of that a table. And they actually ask you, hey, if you're successful, what is Dave's password? And you see that it's actually the word password with an uppercase O, a 0, a R, and lowercase r and a uppercase D. All right, so let's actually try to do a union query, right? And in this case, I'm going to start also with a single quote, and I'm going to do a union select. And then in this case, we want to look for probably integers, and where you can probably substitute, let's say, a 1 for something else, right? And that can actually probably cause some behavior and response from the server, and then and of course potentially retrieve records back, right? So of course I already know what is the solution in here. I'm going to walk you through it. This again can take several minutes or hours, right, or probably days, depending on the individual, right? But in this case, what I'm going to do is I'm going to do union select 1, so an integer of 1, and remember that we actually have username, password, cookie. So remember that we actually have to match those, right? So we can actually type user underscore name, and then password, and then cookie. And then basically what we can do is enter 2 more elements, like A and B, and then 1 to, well, actually, let's try that, right? So let's do A, B, and then the number 1. And remember that in the beginning I mentioned that your SQL statement has to actually match the different elements of the actual table, right? But since we already know that we have a few elements in here like username, password, cookie, and so on, we probably want to match these 3 others, right? So we have 3 here and 3 others. So I'm gonna put just A, B, and then a 1 for the login count, right? And again, the reason is that the data type of a column in the first select statement must have the same or similar data type to the one in the second select statement for this table. So we already know what is actually happening in the user data table, but what we want to do is manipulate the user system data table. So at the end, to do that, what I'm going to do is a from, and then user system data, and then I'll do the comment again. Oops, only 2. And then if you click on get account info, okay, something went wrong in here. I probably had a typo. So let's see. So union select 1, and then user underscore name, then password, cookie, making sure that I didn't spell it incorrectly, A, comma, B, all be in single quotes, and then 1, and then from user system. That's the problem right there. I was missing an M, underscore data, and then of course, closing the semicolon, and then having the 2 dashes for a comment. So let's try to retrieve that, and you see that we were also successfully to retrieve the contents of that table. And now we actually have, the different passwords, and Dave's password now is different order, but you see that it's actually the word password, with an uppercase W, uppercase D, and a 0 instead of an O. What I also invite you to do is to go over the mitigations as well, right? And some of the mitigations explanations, of course, they go in very detail, even through the code on what you should implement, especially if you're a developer, right? And one of the things to mitigate SQL injection, and one of the most common things to mitigate SQL injection is parameterized queries. Now, some of these mitigations also will have different exercises. I'm not going to go there today, but let's explore other vulnerabilities that we actually have in here, right? And learn, but let's explore other exercises and learn different vulnerabilities that we have in WebGoat. So if we go to authentication bypass, of course, it gives you a very good summary of what authentication bypass, and that in this case, usually takes advantage of some type of configuration or logic flaw, and you can actually perform tampering or fuzzing, or be able to manipulate different input fields, whether they are hidden fields or removing parameters, or do forced browsing and so on, right? So in this case, we actually have an exercise in here where we have an authentication screen that is using a two-factor authentication, right? And as a matter of fact, this was part of the two-factor authentication bypass or vulnerability that was actually, or PayPal was actually susceptible to it back in 2016, right? Now, in this case, it says, using a proxy, remove the security question 0 and security question 1 from the post data, right? So as you learned before, we can, manipulate, different applications and the transactions from your web browser to the application using proxies like Burp Suite. And in order for you to do that, what we can do is actually go over to our preferences and then go all the way down in your browser and go to network settings and then click on settings. And then in here, we actually can do a manual proxy configuration, and we're gonna send that to ourselves. So 127.0.0.1, and then the default port for Burp is port 8080, right? If I click on OK, now all the transactions from my web browser will be actually sent to Burp Suite. So now we can actually navigate to Burp Suite. So we go under Web Application Analysis, Burp Suite, and we're using the Community Edition. And in this case, we're not going to upgrade it right now, but we're going to select a temporary project and select all the defaults. Once Burp Suite gets started, of course, they try to actually, have you upgrade and pay. So we're going to hide that. And you see that now our proxy is already collecting information, right? You see get services, from some lesson that we are in right now. I'm going to turn intercept off for a second. And then I'm going to read this scenario here. So you're resetting your password, but doing it from a location or a device that your provider does not recognize. So you need to answer the security questions you set up, right? Which is their security questions in here. And the other issue, the other issue is that those security questions are also stored on another device, not with you, and you do not remember them. So you have already provided your username and password. So think about that. You already are trying to authenticate. Now you're trying to put your questions, that most applications actually ask you, some personal questions, like in this case is a favorite teacher or the name of the street that you grew up on. And you most definitely recognize this from many other applications that you probably interact on a daily basis, right? Now, what we want to do is with the information that we're going to put in here, we can actually put anything. Put 123, 123 in both of them. Now I want to actually turn on intercept from Burp Suite, and then I'm going to click on submit. If I go back, I'm going to click on forward, and I'm going to slowly go over the different elements or different transactions, and now I'm going to stop on this one. You see security question 0. 123, 123, what we actually enter in here, security question 1. So in this case, what we want to do is, try to manipulate these security questions. So if we have security question 0 and security question 1, we probably can manipulate those numbers or integers in here. And if there's a 0 and a 1, we can probably change it to 2 and a 3 and see if that actually bypasses the other security questions that we actually have probably have in that external system, as just the application actually mentioned, right? So if I click on forward, now you see that we actually have successfully verified the account without actually verifying it, and you can actually change your passwords. And of course, I can actually type whatever password in here and then change my password. So we're successfully able to solve this challenge, right? So let's go over another type of vulnerability, and let's go over XML extended entities. And XML extended entities are pretty fun vulnerabilities, right? And as you can see from the screen, right, it's an attack that can be abused to obtain sensitive information from vulnerable web applications. You can obtain files, arbitrary files from the system, or even do code execution in some cases, right? So I invite you to actually review at least the explanation of XML extended entity. But if you want to go straight to the exercise, as you see in here, this is a website that it mimics social, type of, think about like Instagram, right? So social networking application where you have pictures, you have people posting some, whether it's pictures or comments and so on over the picture. And it actually allows you to interact with the application with, of course, with some input, right? And by the way, let's actually try to manipulate that. And as I mentioned, XML extended entities are input validation vulnerabilities. And in this case, the problem is how the XML parsers process data, and vulnerable applications then can allow you to manipulate the system to be able to escape the web root folder and obtain other sensitive informations. Like what we're going to be doing here as a start is to try to get all the files and directories, at least the directory listing and the files of the root folder, but not the web root folder, if not the root folder from the file system. So we're going to escape the web root folder and try to go to the root folder of the underlying host, right? So what I'm going to do for this exercise is I'm going to use burp. I'm going to turn on intercept, and then I'm going to type a comment in here, and I'm going to just type, oops, let me go back. I'm just going to type in here, hello, and then go back to burp, and I'm going to forward that until I see my comment. And then as you see in here, we actually have an XML transaction or XML document in here. And it starts with a comment tag. And then you see the hello text. And then, of course, it closes the tags. So what I'm going to do is I'm going to add my own XML strings in here. I hate to say code because it's actually not code. And basically what I'm going to do is I'm going to do a doc type comment. And this comment can be anything. And then entity XXE, and again this also XXE can be anything that you would like, but just for simplicity I just name it XXE, system, and then file, and then I'm going to try to actually list all the files and directories from the folder. And I just noticed in here that I'm missing a greater than sign. And then you see the comment, the text, and here I'm actually just putting Omar was here, and I'm appending the output, and if I'm successful of this sifting call, to actually be able to list all the files and directories in the system. So if I forward that, and if I go back, now you see that my comment is here, along with all the different files and directories of the root folder. So if I do this one more time, and I do hello, again, go back to burp, look for my hello comment. I probably have to, oops, I actually just pass it in there. So let me turn off intercept and let's do it again. So I'm going to do hello, and you have to be quickened sometimes, because if you click too much in the forward or drop button, you're gonna run into problems like you saw right now. So I'm gonna turn on intercept, submit my comment, go back to burp, forward, and then in here, similar to what you saw before. But now what I'm going to do is I'm going to try to enumerate the etc password file. So I'm going to try to get the password file from the system. And I'm also missing that tag. And then I'm going to forward this. And now you see that we were able to obtain the contents of the password file on that system. So if you're a developer and you're listening to me, please do not run your applications as root. If you run your applications as root, I'm also going to be able to obtain the contents of the shadow file and then be able to crack all your passwords. So again, there are many other exercises and challenges here in WebGoat. Let's actually take a look at one more, and let's go over cross-site scripting. And in previous videos, you already learned what cross-site scripting is, right? You know that the cross-site scripting targets a user, right? To either redirect them to a malicious site, to steal the cookies, to then be able to do session hijacking attacks, and many other type of conditions, right? So redirecting them to download malware or to enter sensitive information to a fictitious, website, or whatever the case might be, right? And you also learned that there are three types of cross-site scripting. There's reflected, there's stored, and DOM-based cross-site scripting. Now, reflected is non-persistent, and stored is persistent. So in other words, the vector gets stored in a database or a file within the system or the application. Now, DOM-based is a type of cross-site scripting that is also a non-persistent. It's a type of reflected cross-site scripting. And then, of course, here they actually go over many different exercises and many different explanations of what cross-site scripting is, right? For example, in this case, we have a note that many modern web browsers, including Chrome and Firefox, already filter out and ban different JavaScripts from the URL or the URL bar, or actually from input in many different things like forms and hidden fields and many others, right? Now, if you actually navigate, let's go over to number 7 here, right? Because this one is really simple. You just have to copy and paste, this vector in here, and you will actually see the effects, right? But let's take a look at one that is a little bit more interesting, right? So in this one, it says identify which field is susceptible to cross-site scripting, and you have different fields in here, right? That the user can actually enter some input. You have a credit card number, you have a 3-digit access code, and so on, right? So one of the things that you can actually do, as you learn in previous examples or in previous videos, is that you can actually use the script tag, if I spell it correctly, and then you can pop up alerts like alert, and then Omar was here, and then close that, and also close the script tag. And then you see that I already knew that the credit card number field was susceptible to it. So now you see a pop-up window, right? Omar was here, right? So you're actually able to manipulate the application and at least verify that you have a cross-site scripting condition, right? But as you're saying here, well done, but alerts are not very impressive, are they, right? So please continue. So what we can probably do is after that is identify a potential DOM-based cross-site scripting that may allow you to do other things, right? Now in this case, it says the objective is to find the route and exploit it first through what is the base route. So, and as an example, look at the URL for this lesson. So this is actually the URL, and it should have something like WebGoat start SMB and the lesson, number at the end. So lesson 9. So yes, it actually looks like that. And the base route in this case is the start MVC, and then a hash or pound lesson, right? So you see right here. So this is actually the base route that we want to manipulate. And then the cross-scripting lesson line after that is the parameters that are actually processed by the JavaScript route handler, right? So this is a route, and these are the parameters. So you know that we probably can manipulate this, right? So the first thing is that they're actually asking, so what is the route for the test code that stayed in the app during production? To answer this question, you actually have to check the JavaScript source. So for doing that, I'm actually gonna make sure that burp is not turned on, so the intercept is not on. And what I'm going to do is actually do a page inspect, so inspect the elements to open the developer tools from Firefox in this example, right? And what I'm going to do is I'm going to try to locate the get or the route. So looking for the routes in the specific JavaScript. So to do that, I can go over to the debugger tab, and then here you actually see the JavaScript, and you see the Goat app, and under view we have several JavaScript files in here, and the one that we are particularly interested in is this goat router.js, and in there we're gonna look for routes to find a specific one. So you can do Control F, routes, and then the answer for this question, again, the question was what is the route for the test code, and in this case it's actually the start MVC and then the hash pound, and actually I'm missing a / just like this, and then once I click submit, you see that that's actually the correct information. So if we go to the next exercise, to 11, it says some attacks are blind. So fortunately you have the server running here, so you will be able to tell if you were successful. Use the route you just found, so the test route that we just found, and see if you can use the fact that it reflects a parameter from the route without encoding to execute an internal function in WebGoat. So the function that you want to execute is actually this WebGoat custom JS phone home. So sure, you could just use the console debug to trigger it, but you need to trigger it via the URL or the URI in a new tab. So once you trigger this, a subsequent response will actually come to your browser console with a random number. And then once we actually get that random number, we will put the random number below. So what I'm going to do is I'm actually going to duplicate this tab, since it already has the URI, right? And it doesn't matter, right? It can be the same. But what we want to do is actually get this WebGoat custom JS phone home, right? So I'm going to copy that, and then since we know that the base route is MVC and that the test route is test, and now we can actually put that WebGoat, custom JavaScript. But to do that, I can do a script and then paste that function and then close. But instead of actually closing like that, I'm going to put the %2 and then F for the /, and after that I'm going to put script and then close that tag. And I'm doing this to obfuscate my technique in here, and there's hundreds and hundreds of different vectors for obfuscating, and as a matter of fact, I will close the video showing you several that I have in my GitHub repository. But in here, basically what I'm doing is I'm again using the base route with the test route that we actually saw before, / script, the actual function, and the code that we were provided in the exercise that you see here down below. And then I'm actually obfuscating the closing the tag for script and then just hitting enter. And you see test in here, but actually I'm going to inspect the element again. I'm going to go to the console, and from there you see that the phone home response is this number. So I'm going to copy that number. Actually, see if I can highlight it and copy, and then go back and put this number in here, and you see that we were actually able to successfully use or solve this challenge. And I mentioned to you that there's tons and tons of different vectors to bypass things like web application firewalls and many other protections that modern applications actually have, or even browsers. So I have it in my GitHub repository. So if you go to hacker.org and click on GitHub, it will take you to this page, and under web application testing, I have a markdown page that is called cross-site scripting vectors, and this is a pretty extent collection of different vectors that allow you to obfuscate your technique to bypass a lot of different protections that can be there by default in different frameworks or in web application firewalls. So I hope you have fun, and please keep practicing with all these exercises that we have in WebGoat, and I see you in the next video.